Welcome back to the GCSE Maths Pro YouTube channel. Today's video is a summary of the whole topic of trigonometry, which for this video will be mostly focused on higher tier students, as we will be starting off with Pythagoras Theorem and SOH CAH TOA, which are foundation tier topics as well. However, we will then be carrying on to all of the higher tier trigonometric topics as well, including 3D trig, sine and cosine rules, and the area of a triangle. If you are doing foundation tier, you can look at this summary up to the first two sections. Beyond that, once we hit 3D trig, you do not need to continue watching. If you would like to watch any of these videos in full, they will be all linked down below in the description. So, take a screenshot of this page. This is your summary of the formula. So, what is Pythagoras' theorem even for? As you can see here, Pythagoras' theorem is used specifically in right-angled triangles. Okay, so they have to be a right-angled triangle. When you're given two sides and then you have to find a third side. So it could be any combination of any of these two sides that you're told, and then you have to find whatever the third missing side is. Okay, so nothing to do with angles, just two sides given and one that you're finding out. Once you've figured out that you need to use Pythagoras' theorem, you then have to make sure you label the triangle correctly. So label all three sides A, B, and C. A and B don't really matter between them. The most important one to know and the most common mistake that students make is which side is C. Now, as you can see here, C has to be the hypotenuse. That means the diagonal side. So let's just go straight into it. It's pretty much as simple as that. They might not tell you need to use Pythagoras' theorem. So for example here, the question just says, work out the length of x. Okay, you might have to kind of know, oh, okay, I need to use Pythagoras in this circumstance. But once you've figured out you need to use Pythagoras, it's just a question of labelling the sides correctly and then substituting the numbers in. So, as I said, I always tend to label C first because that's the most important one to get correct. In this case, C, obviously, well, in every case, C is the hypotenuse, but in this case, it is the one that we don't know, isn't it? C is, in this case, x. A and B have to be the vertical and horizontal sides, or the sides that are joined together by the right angle. As I said before, it doesn't really matter if you put B here and A down here. Like, that doesn't actually matter as long as A and B are these vertical, horizontal sides, the ones that are perpendicular. C has to be the hypotenuse. Okay, so now that I've mentioned that a million times, once you've done that, I'm literally just copying the same formula, but substituting in the values. So let me just write it down here so you can see it in the middle. We've got a squared plus b squared equals c squared. Don't forget that they are all squared, because a lot of the time people think it's just a plus b equals c. They are individually squared. But now I know, okay, well a, in this case, is 4, isn't it? So I just put that as 4 squared. B is 3, so 3 squared. And C is technically x, isn't it? So you can put C or you can put x, doesn't really matter. There we go. Then, as you can see, it's kind of just algebra at this point. In this case, I'm going to add together 4 squared plus 3 squared. Okay, so 4 squared plus 3 squared. Obviously, that gives us 25. So I'm going to keep writing out fully, as in as a full equation. So I'm not just going to write equals 25, I'm going to put equals x squared. The reason why I write that is because I'm looking for x, and I need to remember at the end, the answer is not 25, okay? I need to square root. So my final step is to do the square root of both sides of my equation, which is obviously just 5. Okay, so in this case, the answer is x is 5, so 5, obviously, centimetres. There we go. Okay, so label the sides correctly, substitute into the equation, and then solve it. Okay, let's look at another one now. So work out the length of x. In this case, they've said to 3 significant figures. You can see now x is a different side. So our first step is always to label the sides. C is the most important one, so C is the hypotenuse, the diagonal one. In this case, C is 8. And then, as I said, A and B doesn't really matter which one you put it as which, so I'm going to put A here and B here. Step 2. Substitute into my formula. So I know it's going to have to be a squared plus b squared equals c squared. Now, in this case, a is x. You see how the x is in a different place now, it's x squared. Plus b squared, so 5 squared, and equals c squared, which is 8 squared. Okay, so it's in a different format now. I've got the x on the left-hand side. So to solve it, I'm going to have to do a bit of rearranging as well, aren't I? So I might work out the square numbers first. So I've got x squared plus 25 equals 64. Now, if I want to solve this equation, just think literally about algebra now. I'm going to have to get x on its own. So I need to move 25 across, and by subtracting, then it will cancel out, won't it, on that side. So x squared is equal to 64 minus 25, which is 39. And then again, don't forget at the end, we need to square root it. So x is equal to the square root of 39, which it will give it to you like that, but they've asked for 3 significant figures, so I'm going to press this SD button here to convert it into a decimal. 6.24499, so on. 3 significant figures, so we've got 6 is one of them, 2 and 4. Check the next one is 4, so I don't need to round up, so it's 6.24 to 3 significant figures. Okay, so the steps are the same, but depending on which side is missing, you might need to do a bit of rearranging as well. Okay, but that bit is just relating to algebra. Here we have the 3 formulas. So we've got sin, cos and tan. You will have noticed those buttons on your calculator. We've obviously got right angle triangle here with the correct labels, and we've got this acronym SOH CAH TOA. So trigonometry, or in this case basic trigonometry, where we're looking specifically at right angled triangles, okay? So basic trigonometry, SOH CAH TOA, only works for right angled triangles. And in difference to Pythagoras' theorem, which is where we have 2 sides and we want to find the third one, this one we could be given 2 sides but we want to find an angle, or we're given a side and an angle and we want to find another side. So we're still working with 3 pieces of information, but now we're throwing in some angles. That's kind of the difference between Pythagoras and trig. Now we're going to label the triangle similar to Pythagoras, but in this case we've got different letters. So we've got O, A and H, which as you can see here represents opposite, adjacent and hypotenuse. Obviously opposite, that's kind of self-explanatory. Adjacent means next to, right? It's a fancy way of saying next to. So you can see in this case the A is next to, it's the side that's next to the angle. And the hypotenuse is the same as always, it's the diagonal side, the longest side, okay? So we've got opposite, adjacent, hypotenuse. Now the hypotenuse will always be the longest side, but the opposite and the adjacent depend on which angle are we referring to. So for example here, that's why I've labelled this one. This little symbol here means theta. They might use x, they might use theta, but it basically just means I don't know what this angle is. Obviously, therefore, that side is the opposite side, isn't it? Literally opposite the angle. And as I said, this one is adjacent. It's the one next to it that's not the hypotenuse. So for example, if my angle was actually here, the opposite and the adjacent would swap round, wouldn't they? That would be the opposite, and then that would be the adjacent. So it really depends on which angle they're referring to, okay, as to which is opposite, which is adjacent. Okay, there are 2 ways to work out what calculation we'll need, because it depends. Obviously, once you've chosen sin, cos or tan, you then need to figure out actually what am I putting in my calculator. You might prefer to start with these formulas and rearrange them. That's fine. I personally prefer to use the formula triangles because it's still based on SOH CAH TOA. All you have to remember is the middle letter is the one that goes at the top of the formula triangle. The other 2 letters, it doesn't really matter. Okay, so you can see here I've got SOH, CAH and TOA. So feel free to screenshot this one as well if you want to use the formula triangle method. That's the one I'm going to be showing you today. So let's actually get into it and see how it works. So it's kind of similar. The first step is going to be to label the sides, but in this case I'm actually going to only label 2 sides. Because when I use SOH CAH TOA, which you can see I've got up here, it's always based on just a combination of 2 sides. If I label all 3 sides, it's not going to help me choose which of sin or cos or tan I'm going to need. So I'm going to label the 2 sides that are relevant. In this case, obviously the 5 centimeters is relevant because that's helpful information, isn't it? What side is that? Well, as you can see, it's literally opposite the angle, isn't it? So it's the opposite. And then the other side that's relevant is the x, because that's the one I want to find out. And that one is the diagonal, the hypotenuse, isn't it? This one down the bottom is technically the adjacent. However, I don't know what it is, and I don't want to find out what it is. So it's not relevant, it's not helpful to me. So I'm going to ignore that one. Once I've labelled 2 sides that are actually relevant, that helps me narrow it down. Which of SOH, CAH and TOA has both O and H? Well, it's going to be SOH, isn't it? Which represents sin. Okay, on your calculator, it represents the sin button. I don't know if you can see my mouse here. We've got sin, cos or tan. Each question you're going to choose most of the time just one of those. Okay, so sin, cos or tan. In this case, we need to use sin. So step 1, label the triangle with the 2 relevant sides. Step 2, figure out is it sin, cos or tan. This is where I then bring in my formula triangle because, yeah, okay, I know I need to use sin, but what do I actually put in my calculator? So I just scribble a little triangle. You won't get any marks for this, it's just for your own help. So as I said, the middle letter always goes at the top, so the O. We cross out the letter we're looking for, isn't it? So we're looking for the hypotenuse. So if I cross that out, do you see how I'm left with? The the hypotenuse is equal to the opposite, and then S represents a sin, okay? Now, sin, cos, and tan, the buttons on your calculator, always go with the angle, okay? Always with the angle. Obviously, the hypotenuse and the opposite are the sides. So that's my formula. Now I can substitute in what I know. The hypotenuse in this case is x, isn't it? The opposite is 5. And sin of the angle is going to be sin 48. So this is what I need to put into my calculator. So grab your calculator, fraction, 5 divided by, and then you just press the sin button. It will open up a bracket. So you put 48, close the bracket, and then equals. Most of the time you're going to get loads of decimals. So in this case, we're just going to round to one decimal place. That will be 6.7. And because the hypotenuse is a side, I'm obviously going to put centimetres. That's my answer. This is our last question. As we saw with Pythagoras as well, they might not even use right angle triangles initially. In this case, we've got a trapezium. What you can do is draw in lines on any of these shapes to create right angle triangles where it would be helpful for you. So work out the value of x to one decimal place. You can see x is this one at the bottom. What I would do first to create a right angle triangle in the first place is draw a line straight across here pretty much, because that is a right angled triangle, isn't it? Okay, so you can add in lines wherever would be helpful, obviously. Make sure that you know that technically it would be a right angled triangle. Okay, now we've got this triangle, but you're looking at it going, well, I've got 77 degrees, but I kind of need more information, don't I? Two things. One, if I want to find out what x is, if I've drawn a line here, this bottom part is technically a rectangle, isn't it? In which case, that means that the base of my triangle is also x, isn't it? They would be the same length. So all I need to do is use my triangle to find out the base, and then that is the same thing as x down here at the base of the trapezium. But also I still need another side, don't I? I need two pieces of information to find out the third. That's where the 12 and the 17 come in. I could work out the height of this triangle. Now, a lot of people, as I said in the Pythagoras one, kind of look at it and guess. Sometimes it looks like it's half, sometimes it looks like it's a third or a quarter or whatever. Don't ever guess, okay? Nothing's ever drawn accurately, nothing's ever drawn to scale. They should give you enough information to work it out mathematically. So you shouldn't ever really be guessing, basically. In this case, I know that if one vertical side is 17 and the other vertical side is 12, this blue bit I've just highlighted here should be the difference, shouldn't it? So 17 minus 12 is going to give me 5 centimetres. Okay, so I've worked it out in that sense. Look at both of the vertical sides and it's obviously the difference between them. Right, so now I've got my triangle. We're just going to go through and use trigonometry. So label the two sides that are relevant. Obviously 5 is relevant. That one is the adjacent. It's next to the angle, isn't it? But not the hypotenuse. And then the x is opposite the angle. So obviously that's the opposite. So then I go SOH CAH TOA, which one has both O and A, obviously TOA. Get my formula triangle so I know actually what to put in my calculator. Now I'm looking for the opposite, so that's the one I'm going to cross out. So my formula is the opposite is equal to tan, again, of the angle. The angle always goes with the sin or the cos or the tan, times by the adjacent. So in this case, x equals tan of 77 times 5. And that is literally what I'm going to put in my calculator. So tan of 77 times 5. Okay, now because that is the final answer, isn't it? It's x. We can round it straight away. So set to one decimal place, so 21.7. There we go. That's it. Okay, so you might need to create right angle triangles if you don't have any. They've given you an angle, so you kind of know it's hinting towards possibly using trigonometry. These are the formulas that we're going to use. But in this case, we're now going to use it to find angles. So this time we're going to jump straight into it. I'll link below the previous video if you want to go check that out first. It's also going to be in the description. So as we said, trigonometry or basic trigonometry with SOH CAH TOA is related to and only useful for right angled triangles. However, it's different to Pythagoras because we're now using angles, aren't we? Pythagoras' theorem was two sides that we've got, find the third side. In this case, we're going to have a combination of two sides and an angle. Okay, whichever one is missing, it doesn't matter, but we're going to have an angle thrown in there. So, how do we work out angle x? Well, we're going to go through the same steps pretty much at the start. You need to label the sides that are relevant. This time it's a little bit easier because obviously you're given two sides. So the two sides that are relevant here is obviously 8.7 and the 13.5. And we need to label them with either opposite, adjacent, or hypotenuse. The hypotenuse is obviously the diagonal side, the longest one. The opposite is the one opposite the angle they're referring to. So you can see here, this is the angle x. In this case, 13.5 would be our opposite. And then the adjacent, which means next to, is the side that is next to the angle. That's not the hypotenuse, right? In this case, the 8.7 is the adjacent. I only label two sides because when I use my acronym SOH CAH TOA, it's specifically based on two pairings of sides. So you can see here, opposite hypotenuse, adjacent hypotenuse, or opposite and adjacent. If I label all three sides, like that, for example, because that is obviously the hypotenuse, if I label all three, it's not really helping me figure out which one I need to use, is it? So I only label two sides in this case. The hypotenuse is not relevant because I don't have it and I don't want to find it. Okay, O and A, which one has O and A? Obviously TOA. Then we use the formula triangle. So as I said in the previous video, you put this acronym in the formula triangle. The middle letter is the one that goes at the top of the triangle every time. So this time we're looking for the angle. So I'm going to cross out the t, the tan, okay, or the sin or the cos, depending on which one we're using, because we've already got opposite and adjacent, haven't we? So we're not going to cross out either of these two. So for the angle, I'm going to cross out the tan in this case. So when I write it down, I've got tan of the angle. If you remember in the first video, we said the angle always goes with the sin or the cos or the tan on your calculator. So tan of the angle, this is just theta to represent an angle, you could put x if you want in a minute, is equal to the opposite over the adjacent. Okay, so now we can put our numbers in. Tan, in this case of x, is equal to 13.5 over 8.7. So let's put that in our calculator. So 13.5 over 8.7. Now, you're going to look at that and go, yeah, not sure that's correct. Because think about it, this is why I want you to, and I mentioned it in the Pythagoras one as well. Think about it, does your answer make logical sense? We're looking for degrees. Is it likely, and I know it's not drawn to scale, but still, is it likely that that x is going to be 1.5 degrees? No, it's not, is it? The smallest you're probably going to get is maybe 10 degrees, but most likely it's going to be like 20, 30, 40, 50 degrees or something like that. 1.5 degrees or less than 1 degrees, sometimes it's 0 point something, is obviously not the final answer. So we've gone through the same steps as we did for the side. The only thing though is, can you see that that's tan of the angle is equal to 1.55? Not just the angle, not just x. If we think about, this is effectively just an equation, isn't it? If I want to solve an equation, I need x on its own. So I need to reverse or move the tan to the other side of the equation, don't I? So that's where you might see, if you have a look, I don't know if it's really small, but where you've got sin, cos and tan on the buttons, can you see slightly above it on your calculator? You should have sin to the -1, cos -1, tan -1. Those mean the inverse. So what that means is when I'm finding an angle, okay, so only when I want to find an angle with trigonometry, I'm actually going to use these buttons, the inverse. You might have to press shift and then the tan button in this case to get that. So I'm going to do shift, tan. You see how it comes up with tan -1? Then I'm going to put my answer button, which we mentioned in the previous video. Use your answer button. Don't round the numbers, okay, because you'll get a wrong answer. Use the answer button because it will copy all of those decimals. If I put equals, you see how 57.2 now looks like a more reasonable answer, doesn't it? You think, yeah, that's believable. 57 degrees, that seems reasonable. Okay. So to one decimal place, x is 57.2. So when you're finding out angles, everything is exactly the same until the last step. Okay, you have to remember, you have to do what's called the inverse or the -1 of either sin, cos or tan. A lot of people get confused as to when do I use the -1? Only when you're trying to calculate an angle. As you saw in the previous video, we were only looking for sides, so we never used the -1 buttons. Okay, so similar to the previous question, we've got a couple of questions which are a little bit more complex. Still the same trigonometry, okay, still the same working out, but it might be a bit longer. So in this case, work out the angle x to one decimal place. You can see it's the one down here. We get this scenario quite a lot. We need to have two sides in order to work out an angle, don't we? We need two pieces of information in order to work out the third. You look at this right-hand triangle, I've only got one piece of information, one side. So clearly it's not enough. I already don't have enough information about this triangle over here. So I'm going to have to jump back to the left-hand triangle first, see what I can work out over there that might help me with my right-hand triangle. Now in this case we've got this rectangle in the middle. Obviously rectangles, the opposite sides are the same, aren't they? So this dashed line here is the same as the dashed line on the right. So if I can use my left triangle to work out the dashed line, I can then just copy that number over here, can't I, for my right-hand triangle. So that's what I'm going to do. I need to work out this dashed line. So we're going to go through the same process. We need to label the sides. Now this one overlaps with our previous video because we're working out a side, okay? So if you haven't watched that video, go check it out. I've linked it down below. Label the two sides that are relevant. Obviously, the one we want is the opposite in this case, isn't it? And the one that we have is the hypotenuse. So I'm using sin. So step 1, draw my formula triangle so I can work out what to put in my calculator. I'm looking for the opposite. Cross that one out. My formula is the opposite is equal to sin of the angle times by the hypotenuse. Now in this case, we've got sin of 80 and then times by 6.8. That's what's going in my calculator. So sin, just normal sin, not the inverse because we're working out a side. Close the bracket, times by 6.8. Okay, this is another situation where we're kind of halfway through the question, aren't we? This is not the end of the question, so I don't want to round this too soon. I also don't want to have to write down all those decimals. So I'm going to write down a couple, maybe 2 or 3 decimal places. But in your calculator, you're going to copy this answer, okay? So you see where at the bottom it says A and S? That is the answer button. It means it will copy the whole of this answer next time we use it. So I'm just going to put 6.696 ... As we said, obviously we know it does carry on. So this is 6.696. And as a rectangle, obviously this other side is also going to be the same, isn't it? 6.696 ... So now I can jump over to my actual triangle over here. I want to work out x. So label the two sides that I know are relevant. So obviously the opposite is the one we just worked out, and the one that we're given as well is 4.9. That is the adjacent, isn't it? It's next to my angle. So step 2, SOH CAH TOA, I need to use TOA. So TOA in my formula triangle. In this case, because I'm looking for the angle, I'm going to cross out the tan, the T, because I've got opposite and adjacent already, haven't I? So my formula is tan of the angle equals opposite over adjacent, and if I put in the numbers that I have, obviously we can put x for the angle equals the opposite, which is 6.696, isn't it? However, I'm going to be using my answer button in reality, okay? I don't want to round it too soon. And then over 4.9. So I get my calculator. You see how I still have my 6.696 ... I'm just going to go straight and do, because we know it's an angle, I want to do tan inverse, don't I? So tan inverse, fraction, then I put my answer button. That will copy the whole of that decimal, not just the couple that I wrote down. Over 4.9, close the bracket on the outside. There we go. To one decimal place is 53.8. So in that case, I did have to use the tan inverse, the tan to the -1, because I'm working out an angle, okay? So just don't forget that bit. Double check, does my answer make sense? Well, yeah, that seems reasonable, doesn't it? 53 degrees. Okay, so it's not really anything different in terms of anything additional or anything new. All it was is we had to do the same process twice. So 3D trigonometry sounds really complicated, but it's literally the exact same thing as just normal trigonometry, except it's in a 3D environment. So what I mean by that is here we've got a 3D shape, however I'm going to be finding still 2D triangles within that shape. Work out the angle DFA to one decimal place. So these often require that we're going to draw in some lines and some angles ourselves as well. You can always annotate any diagram that they give you. So here DFA, I'm going to draw that angle in, which means I need to draw a line from D to F and then a line from F to A. And we're looking for this angle here. So that's our end goal. Now often these types of questions require 2 steps. Now whether that's just both trigonometry or it could be a Pythagoras step and then trigonometry afterwards. It just depends. So while it's called mainly 3D trig, we're also going to be using Pythagoras, bear that in mind. Now as you can see, this creates a stood up right angle triangle, doesn't it? So SOH CAH TOA is still going to be used in the exact same way. If I look at this triangle, DFA as a triangle, I want to find out the angle, which means I need to know 2 sides. Now, I've got here that BC is 6.7, which means that AD is also that, isn't it? Given that we have a cuboid. So I'll just put that in pink so we can see it. So that is 6.7 in height. However, I don't have another side. So then I have to decide, okay, does it make sense for me to work out DF or AF? Given that we've got some information about the base of my cuboid, it's probably easier for me to work out AF. So in a similar way, if I look at this triangle at the bottom, ABF as a triangle flat on the base of my cuboid, 5.2 centimeters is the same over here, isn't it? And I have AB, which is 9.8. So if I look at this bottom triangle, ABF, I have two sides and I want the third one. So actually, that's going to be Pythagoras, isn't it? So step one, I'm going to use Pythagoras' theorem. That's where we label the triangles with A, B, and C. C always has to be the hypotenuse, isn't it? So A and B don't really matter between them. C has to be the hypotenuse. So I've got A squared plus B squared equals C squared. If you want to recap on how Pythagoras works, I will link the video here. So I know that A is 9.8. So I've got 9.8 squared plus B is 5.2 squared equals C squared. In this case, I don't need to rearrange it. I'm just going to put it in my calculator. So 9.8 squared plus 5.2 squared gives me 123.08. However, just remember, obviously that is C squared. So I am going to need to square root it to get C. As you can see, there's quite a few decimals and it's not the end of our question yet. So while I might write down a couple of decimal places, I'm going to just keep this answer here on my calculator so I can use it later. Let's just go with 11.09 ... So now we know what AF is. So that is 11.09-ish. Obviously, again, it has a load of decimals, so don't forget about that. Don't round it too soon. Okay, now I'm looking back at this triangle DFA in the middle, okay, the one that's vertical. My end goal was to find this angle, wasn't it? Now I have two sides that I know I can use trigonometry to work it out. So we label the two sides that are relevant. In this case, 6.7 is the opposite and 11.09 is the adjacent. So step 2 is going to be trigonometry. If I think about SOH CAH TOA, I'm going to need to use TOA. So I fill out my formula triangle, cross out the one I'm looking for, obviously is the angle, which is tan. So I've got tan, I'm going to put the angle as DFA. So tan of the angle is equal to opposite over adjacent, so 6.7 over 11.09, but again, remember, I'm going to put my answer button as the 11.09 in my calculator. So you can see here, I still have the 11.09. I can go straight to doing the fraction. 6.7 is at the top, and at the bottom, I'm going to put answer so that I don't lose any decimals. Equals. Obviously, you know that's going to give you a 0 point something number, which is not correct. We need to do tan inverse, so tan minus 1. Answer again, and there we are. So our angle is 31.1 to 1 decimal place. And there we have it. That is literally it. Okay, so we've looked at some where they are all cuboids, but they might not actually all be the same shape. Here we have a triangular prism, so it could be any kind of 3D shape, most likely a prism though. So we've got work out the angle between AF and the plane ABDE. So initially I'm going to label my diagram because in this case I don't have it already on there, and then I'm going to draw some lines to help me as well. So we've got CB, which is 7.9. We've got AC, which is 11.5. And we've got the angle AFC. So I'm actually going to draw a line between A and F. Not only because I've got the angle here, but also because in my question it's asking for the angle between AF as a line and a plane. So I've just drawn the line between A and F. This angle here is 53. Hopefully we can see that fairly clearly. And then I want to identify the angle I'm actually looking for, right? So I've got, it's the angle between AF, so this line, and the plane ABDE. If you ever get it where it says between a line and a plane, the plane basically means the base, right? So in this case, ABDE is the base, so that side of the prism. However, it's quite hard to figure out what they mean by that angle. Is that referring to here? Because that would be the angle between AF and AB, not the plane, right? So what I'm going to do is draw another line diagonally across my plane. Now in this case, the more helpful diagonal is A to E, isn't it? Not DB. So I'm going to draw a line like this. Okay, it's going diagonally across my plane. Now if I draw the angle I want, it's that one. So that triangle in the middle with the dashed lines is like standing vertically, isn't it, effectively? This is like the right angle there, and it's standing up vertically. So that's what I want. If you ever get this question, it should look a little bit like that. It could also be with a cuboid, but in this case, we have a triangular prism. So now let's start looking at triangle AFE, right? The one with the dashed lines. I currently technically only have one piece of information, don't I? Like the 7.9 is obviously going to be the same for EF as it is for BC. However, I don't have anything else. Okay, I don't have the angle, which I'm looking for, and I don't have any other sides. And I always need two pieces of information when I'm trying to find out something using trig. So I need to find something else, obviously most likely going to be a side. So now I'm going to have a look around at any other triangles I can pick out. The 7.9 I can assume is for using in that triangle, so I'm not really looking at that. I'm going to look at the other two pieces of information that I have, the 53 degrees and the 11.5. Now those two both are for this triangle up here, aren't they? The triangle ACF. So 11.5 is AC and then the angle is here. I could actually use that. You can see we've got a line in common. Just underneath it you can see the dashed line. It's in common with AF. So I'm going to use that triangle first to find out the side AF. And because it's an angle and a side, and I want another side, obviously I'm using trig, I'm not using Pythagoras in this case. So we're going to label the two sides that are relevant. We've got 11.5, which is the opposite this 53. And then the AF, which I want to know, is the hypotenuse, isn't it? It's the diagonal. So I've got, in this case, sin I need to use. So draw my triangle. Okay, I'm looking for the hypotenuse, cross that out. So my actual calculation is the opposite divided by sin of the angle. So in this case, 11.5 divided by sin 53. So let's put that in the calculator. So we've got 11.5 over sin 53. Okay, so we've got 14.39956 ... If you want to write down all the decimals, feel free. I'm going to try and keep it in my calculator as the answer. I'm going to write down maybe a couple of decimals, so 14.399 ... Okay, just to remind myself, it's not rounded. So I now know this one is 14. Let's just say 4 for now. Don't use 14.4. Just write down that if you're happy to, but don't use that number in your calculator because it's not exact. Okay, so now I know that one, I can come back to the triangle that I actually want. So I'm going to rub out this pink triangle just for now. Okay, now we can see it a little bit more clearly. So we're now back to the actual triangle that I want, which is now this green one. So if CB is 7.9, then so is EF. I'm going to write it in green so we can kind of see it a bit better. And we've got our 14.4. The 11.5 isn't really relevant anymore. We don't really need that. And that's the angle we're looking for, isn't it? This one in the bottom left corner. So now I've got two pieces of information for that green triangle. I've got two sides. I can use that, again with trig, to find out my angle. So I need to label the sides. 7.9 is the opposite, and 14.4 is still the hypotenuse. So in that case, I need to use sin again. But this time I'm looking for an angle, so I'm going to cross out the sin part. I've got sin, let's just call it x, the angle, is opposite over hypotenuse, which is, in this case, 7.9 over, now again, remember, I'm going to put 14.4, but in my actual calculator, I'm going to use my answer, which is the 399 ... So you can see here, I've still got my answer there, I haven't cleared it, and if I use the answer button, it will copy it, so I'm going to do fraction 7.9, and then answer, okay? I haven't pressed equals since then, so it's still the same answer. Now, obviously, you are going to get a number less than 1, as we said before. Because it's an angle, I do need to do sin inverse, so you can see I pressed shift, and then the sin button, you get this sin minus 1, which is called inverse, and then put my answer again, copy all the decimals. There we go. Now, this is my actual angle. This is angle X in this case. So we're going to round it to one decimal place. We've got 33.3. So first we're going to be looking at how we label the triangle, as we have moved away from SOH CAH TOA now. We're not using right angled triangles anymore. The sine and the cosine rules are for any type of triangle that's basically not a right angled triangle, okay? So we no longer have hypotenuse, adjacent, opposite, all of that. We now just have A, B, and C as the uppercase angles, and then directly opposite each angle would be the lowercase letter. So in this case, we've got angle A at the top, and therefore side A, which is lowercase, will be directly opposite. And as you can see, that works for all of the letters. It doesn't necessarily matter which angles are A, B, and C, as long as you match up angle A with the correct side A, which is opposite. Now, here we have the sine rule. It is just one rule, however, there are two different formats for working out different things. Sometimes with trigonometry we work out sides or lengths, sometimes we work out angles. On your formula sheet you will get one of these, however they won't list both of them. So you just have to know that in the case of sine rule, whatever you're looking for, whatever the question is asking for is what you put at the top of the fraction. So you can see here we have sine rule for sides. Do you see how the lowercase letters, which we know are the sides, are at the top of the fraction? In the case of angles, you can now see that we've got sine A, sine B, sine C. So the angles, obviously angles always go with sin, cos or tan, right? So in this case, they go as sin, are at the top of the fraction. So you just basically take the formula they've got and flip it upside down if it's necessary. As you can see here, I've got a triangle labelled as well. Now, we do have three parts here. We've got two equal signs and three parts. Obviously, equations only have one equal sign. So what you're going to be doing is only ever using two parts, okay? So what I mean by that is it could be A and B at the same time, it could be B and C, or it could be A and C. It doesn't really matter as long as you've only got two. You're not going to use all three at the same time, okay? So for sine rule, we're going to use it when we've got two pairs of opposite sides and angles, including whichever one is missing. So if you're missing a side or an angle, that's included. For sine and cosine rule, we're going to have four pieces of information. We said for SOH CAH TOA and normal trigonometry, we only had three, didn't we? Again, including what's missing. So you can see here, I've drawn some examples. We have side A and angle A and side B and angle B. If I had those, including, let's say, one that was missing, I would use whichever of these two formulas I need. So if it's for sides, I would use the top one. If it's for the angles, I need to use the bottom one. So for sine rule, the key is I've got two angles and two sides that are opposite each other. So the first one we have, work out the length BC to one decimal place. So in this case, we're looking for a length. That's why I've given this version of the formula where the lowercase letters are at the top. Those are the sides, aren't they? In this case, obviously, I normally only label the angles. So I'm now going to label the sides that are relevant. I've got, obviously, BC. That's the one I want to find out. That's obviously relevant, isn't it? So which side is BC? Well, can you see how it's opposite A? Angle A. So that side is going to be side A. Okay, and then the other thing that's relevant is going to be, we've got angle B, and then we've got the side opposite that, which would be, therefore, side B. In this case, you see how side C and angle C are not relevant at all. I don't have C as an angle, I don't have it as a side, I don't want to know what it is as an angle, I don't want to know what it is as a side, so it's not relevant. In this case, I'm going to be using A and B as my two pairs. So now I just need to basically just sub it into the equation. So side A in this case is BC, you can call it BC, you can call it A, you can call it X, whatever you want. We don't know what it is, do we? So just call it something as a letter. Over sine of the opposite angle, which is 68, equals side B, which we now know is 20.4, over the angle B, which is going to be sine 32. Now, we do have one step to do with sine rule, with rearranging, because at this point I can't really type this into my calculator, right? I need to have BC, or whatever I'm looking for, whatever I'm trying to work out, I need that as the subject. So can you see how I will have to move sine 68 to the other side of the equation? Now that's just normal rearranging equations. As you can see, it's currently divided by that, isn't it? It's divided by sine 68. So if I want to move it across, I'm going to have to times by sine 68. So my actual equation to find out BC would be BC equals, this whole fraction here is fine, so 20.4 over sine 32 times by sine 68. Now that is what I'm going to type into my calculator, and then we will get our answer for BC. So this is obviously going to be a calculator question. Make sure you have your scientific calculator, not your phone calculator, because that will not work. So I'm going to type in, I've got my fraction, 20.4 over sine 32, just remember to close the brackets in your calculator, times by sine 68 equals. Here we go, that's my answer for BC. So it said to one decimal place, so that will be 35.7. And it's a side, which is in centimetres. And that's your answer. Okay, let's look at the next one. So this time we want to work out angle BAC to 1 decimal place. So we've got an angle to work out. You can see that's why I've put the angle version of the formula at the top here. So let's see, we want BAC. That's obviously the one with A in the middle. So here, this is our angle that we want. So I'm obviously going to label the side opposite that because that's relevant, isn't it? That's going to be side A. And then in this case, I've got angle C and I've got the side opposite that, which is therefore side C. So for this one, I actually don't need B. Not helpful at all. I'm going to use A and C, and again, you just put them equal to each other. And we just substitute it in. So now that I've done that, I'm going to substitute it in. I've got sine of the angle A, which I don't have, so I'm just going to call it angle BAC, over side A, which is 9.5, equals sine of the angle 56 over 12. And again, I'm just in that same situation. I just need to rearrange this equation to get sine of the angle BAC as my subject. So in the same way we did the previous one, to move the 9.5 across, and we're just going to have to times, aren't I, basically? So even for angles, it's kind of the same idea. So my fraction is still fine, sine 56 over 12, and then I would times that by 9.5. And at this point, we just get our calculator. So fraction, sine 56, close the bracket, remember that. Otherwise it might give you an error, times by 9.5. Now, you get this answer, which, considering we're looking for an angle, it's clearly not 0.65 degrees, is it? Let's just be honest, that's not realistic. This is very similar to when we did SOH CAH TOA. When you're trying to work out an angle with trigonometry, whether it's SOH CAH TOA, whether it's sine and cosine rule, you're always going to have to do sin inverse, because you see how here I've got sine of angle BAC equals. That's not just angle BAC, is it? That's sine of the angle. So I'm going to have to do sin inverse. So when we do shift and you press the sin button, you see you get the -1. Press your answer to copy all of those decimals. Do not round it too soon. Equals, now do you see it's seeming a bit more realistic, isn't it? 41 degrees. You think, yeah, that's a bit more realistic. 41.0 degrees to 1 decimal place. In this case, 1 decimal place, I know it's 0, seems a bit pointless, but it does say 1 decimal place, so you have to put the 0. It has to be at least 1 decimal place. Okay, so that's 41 degrees. So just remember at the end to do sin inverse, or in the case of, if you're doing with the cosine rule, cos inverse, whenever you're working out an angle. Otherwise, the method is basically exactly the same. So here we have the two versions of the cosine rule. Again, with trigonometry, we can look for sides or we can look for angles, hence why there's two versions. Normally in your formula sheet, I think you're given this first one, in which case either you've got two options. If you have to use cosine rule to find an angle, you'd either memorize this version or just be confident enough with rearranging that you can take this one and rearrange it to get cos A as the subject. Whichever one you prefer, that's up to you. Now, with cosine rule, we're going to use it when we have 3 sides and 1 angle. As I said in the previous video, with sine and cosine rule, you're going to have 4 pieces of information, not 3. So SOH CAH TOA, you normally have 3, don't you? With sine and cosine rule, we're going to have 4. That's including whichever is missing, so whichever side or whichever angle they want you to calculate in the question, that's included. In this case, with cosine rule, you're going to have 3 sides and 1 angle, okay? So sine rule was 2 sides, 2 angles, so like 2 pairs. In this case, you've got 3 sides and 1 angle. Normally, so for example, A here, if we're trying to find out A, we've got 2 sides and we've got the angle between them, and that's how we find A. So let's get straight into the questions. So here we've got work out the length BC to 1 decimal place. We're going to start by labelling the sides that are relevant. In this case, because it's cosine rule, we need 3 sides. So obviously BC is relevant because I actually want to find that out. That one is opposite angle A, isn't it? So that's side A. And then I know that I need the 2 sides that surround the angle. So this one would be side B because it's opposite angle B, and this one would be side C as it's opposite angle C. Once you've done that, we're just filling out the formula because I've got the formula here on each question and it will be in the right format. So in this case, we're finding a side. So I need to have the side version. So I've got a squared equals b squared plus c squared. It doesn't really matter which one is b and c as long as the 2 of them are correctly b and c. It doesn't matter which way around they go. Minus, now I'm going to write it down how I type it in my calculator. 2 times b times c times by cosine of the angle between them, which is 75, and then close both brackets. So make sure to grab your scientific calculator and type this in. I would just type it in all at once. You can type it in parts if you want, but I think this is easier. 2 times 19 times 26 times cos, remember it's now cos, not sine anymore, double bracket closed, equals that. Now, you're going to get a number like this, which is really big. The reason why I write down a squared equals, I write down the full formula, is because this is a squared, this is not a, right? So a squared equals 781 point whatever it was, ... But with cosine rule, you have to then square root. Okay, you have to square root to get an actual side length that seems reasonable. So square root symbol, answer, okay, don't cut off any decimals, don't round it too soon. Now this seems more reasonable, doesn't it? It's within the realm of 26 and 19. So that is the answer. 27, and now we want to round it to 1 decimal place, so 27 would actually round up to 28.0, wouldn't it? 28.0, you have to put the 0 there. I know it seems a bit pointless, but if they want 1 decimal place, you have to put 1 decimal place, right? So there you go. Your answer is 28. It seems like a reasonable answer. So just don't forget, you do have to square root your answer at the end, okay? But that's it. Other than that, it's just, again, a bit more substitution. So let's look at the next one. Okay, this time we want to work out the angle BAC, which is angle A. So we want to work out this angle here. Obviously, I put the rearranged version of the formula there because we're trying to find out the angle. So we need to label our sides. We've got angle A is the one we want to find out. So therefore, this one has to be side A. And same as before, this one's side B, it's opposite angle B, and this one is side C, opposite angle C. So now I'm just going to fill out this version of the formula. So I've got cosine of angle BAC equals B squared plus C squared minus A squared this time. Now we actually have A over 2 times B times C. And that's what I put in my calculator. Okay. Now you can see I've got an answer, 0.65. Again, we're working out an angle. Same with sine rule, same with SOH CAH TOA. When you're working out an angle with trigonometry, or some version of trigonometry, you're going to have to do the inverse, so the -1 version of sin, cos, or tan. In this case, obviously cos. So 0.65 is obviously not degrees, it's the answer to cos of the angle. I want to get rid of the cos effect, so I need to do shift cos, so that gives me the -1 version. Click answer, okay, so don't cut off any decimals, just click the answer button, it will copy everything. And then I've got my answer. That's actually an angle, that seems more reasonable, doesn't it? Again, we want to think, does our answer seem reasonable or have I missed something? So angle BAC to 1 decimal place is 48.8. There we go. So in this case, when you're finding a length, you need to square root. When you're finding an angle, just remember to do the cos inverse. So I've got this here as the sine and cosine rules, but it does relate as well to using this formula, this trigonometric formula for the area of a triangle. It's going to be used for triangles where they're not right angles, but also normally with a triangle, you would do base times height over 2, or you might have seen it as half base times height. Yeah, that is still area of a triangle for sure. However, that relies on the height, and that's not just any height. That is normally the perpendicular height, which in this case would look something a little bit like that. Okay, that would be the height, and then this would be the base. So if you're not given this height, because that's not actually a side length, is it? If you're not given the height, if you only have the diagonal sides, this is when we're going to be using the formula that we have here. So the formula is half AB sine C, hence why we still need to use the same letters that we had in the previous 2 videos on sine and cosine rule. In this case, we've got the formula based around AB sine C. So it's basically this angle and then the 2 sides that surround it. You might need to scribble out and change the labels. If they've got A here, you might want to change it just so you know that you've got letters in the same place and not have to change the formula, that's fine. But effectively we're looking for 2 sides and the angle between it. That's how we can use this to find the area. So let's get straight into it. If it just says simply work out the area of triangle ABC to 1 decimal place, again you can see we can't work out base times height over 2 or half base times height because we don't have the perpendicular height. So we have to use trigonometry. So in this case, I'm going to label sides. Luckily, angle C is in the right place. I've got angle B and therefore this is side B, angle A and therefore this is side A. So I've got A and B and the angle between them. So the area equals, we just sub it into our formula now, half. Now these are all just times together. So 3.8 times 4.5 times sine of the angle 72. Make sure to close all your brackets. Now, you obviously will need a calculator for this one, but particularly your scientific calculator. Do not try and use your phone calculator because that will be a nightmare. So half, you can put it at 0.5 as well if you want, times 3.8 times 5.4 times sine of the angle 72, close the bracket, and there we go. We don't need to do anything, that is literally just the answer. So it said 1 decimal place, we've got 9.8, in this case centimetres squared. Okay, we've got 2 more, but now these are going to be just a little bit more complicated because, as you can see, the actual thing is quite straightforward, isn't it? You just substitute it in. So they might try and make it a little bit more complicated. In this case, they've given us the area already. So they've said the area of triangle ABC is 23.5. So 23.5, I don't know why I like to put it in the middle, but I just do for some reason. Work out the angle BCA. So BCA is this one. Okay, luckily, angle C is the one that it's based in, and we've got the 2 sides surrounding it. So that's side B and that's side A. So I'm going to set up my equation, but again, now I actually have the area, don't I? So instead of writing A, as in the area A, I can write down the number 23.5. Then I have half side A, which is 10.8, times side B, which is 9.6, times by sine of angle BCA, which I don't have. So always set up your equation, put it equal to the number they've given you. Now I actually just have to do some rearranging. What I'm going to do first is probably work out these 3 things times together before I move anything. So I want to have sine BCA as the subject, don't I? So we'll do half times 10.8 times 9.6 first, just to find that out. Probably not going to be great. Oh, not too bad of a decimal. That's fine, so I'll write that down. So I've got 23.5 equals 51.84 times by sine BCA. So actually, when I rearrange this, it's just algebra now, I want to move this across, don't I? And because they're currently times together, that means I'm going to have to divide. So divide both sides by 51.84, or your answer button, obviously, if it's a massive decimal. So on the right side, we'll get just sine BCA left. And on the left side, I'm going to use my answer button. So 23.5 divided by answer is a really, really bad number. So maybe it's better if you don't write it down. You could write it as the fraction if you wanted to, but I guess I'd probably skip writing that down. Okay, and again, we keep saying this, anything to do with trigonometry, whether it's SOH CAH TOA, whether it's sine rule, whether it's cosine rule, whether it's this trigonometric area formula, if you're trying to find an angle, obviously at the end, you're going to have to do the inverse of either sin, cos, or tan, in this case obviously sin, because the angle is obviously not 0.4 degrees. So I now need to do sin inverse, so you press shift and then sin. Answer button, don't round it anywhere near to the middle of your working, you have to round it only at the end. So use your answer button every other time. Okay, that seems a bit more reasonable. It's now saying 26.95 degrees. I'm probably going to round it to 1 decimal place, so that would round to 27.0 degrees is equal to BCA. Okay, so don't forget at the end to do the sin inverse whenever you're working out an angle with any kind of trig. So that is everything you'll need to know for the topic of trigonometry if you're doing higher tier. If you want to go back into any more detail or check out any more examples, then all of the full videos will be linked down below for you to have a look at as well. If you have any questions or comments, please leave them down below and make sure to like and subscribe.